All right, here's 3.1.2, portions as percents. So your goal is to understand percents as a way to express and compare portions of a whole, all right? So for a little bit of a review, I want you to add these following fractions. It says use the giant one supports if needed. I'm not going to show you those yet. I will show you those in just a second. But do remember, I want you to try adding these fractions, but remember they must have a common denominator. The number in the bottom must be the same. Okay, so go ahead and give that a try. Come on back. All right, so I'm assuming that you had a chance to try these two problems, right? And look at all of this giant one stuff that I have down here. Like, how in the world can we use this to do our addition? So what I recognize is I notice that 12 and 3 are not common denominators. So what I'm looking for is the least common multiple of 12 and 3. Now we've been doing a least common multiple in some of our homeworks. What's the smallest number that both 12 and 3 will multiply into, right? And in this case, the best choice is 12, right? 12 is easily rewritten as 12, and 3 times 4 is 12. So what my goal is to make these denominators the same, and they should both be 12. So if I look at the top one, that's really easy. 12 times 1 is 12. Well, that's a giant one. Moving around on me. And 5 times 1 then is 5, right? So that one didn't change, no surprise, 5 twelfths. But let's look down here. I have 3 times what number is 12? That has to be 4. Right, 3 times 4. But to be a giant one, this also must be 4. So 1 times 4 is 4. So now I say 5 twelfths plus 4 twelfths is, right, 5 times 4 is 9, or 9 twelfths, right? So my answer is 9 twelfths. Now, that's a good answer. It's not a great answer, though. And if you wrote that down as 9 twelfths for right now, at the beginning of the year, I'd be like, that's fine. By the end of the year, I'd be like, that's not okay anymore, right? Because you can simplify this. And to simplify this fraction, we can simply take and recognize that both of them, numerator and denominator, have a 3 in them, right? And if I divide them, why is this moving all over? When I divide them both by 3, I have a 4 here and I have a 3 there, right? Divide them both by 3. 9 divided by 3 is 3, and 4 divided by 3, 12 divided by 3 is 4. Okay? All right, let's try this on the right side here. Let's see how this one works out. Okay. I notice I'm going to put my 4/5 here, and I'm going to put my 3/4 here. The nice part is you can use this for subtraction also. All right, so common denominator, or least common multiple of 5 and 4. Now the least common multiple is actually 20. And 20 is really a great choice to do that. Some of you may not have seen that and said, oh man, what about 40 or some other number? But if you did it with 40, it actually would work. It would be perfectly fine. But the best choice in this case is still 20. So I need the 20 here and I need a 20 here. 5 times 4 is 20. This has got to be 4 over 4. So 4 times 4 is 16. And then the bottom one, 4 times what number is 20? That's 5, right? To be a giant one, that has to be 5. So 3 times 5 is 15. So now I'm looking on that far right side. 16 twentieths plus 15 twentieths is not 21 fortieths, but not 31 fortieths, but it is 31 twentieths, right? The denominator doesn't change. We don't add our denominators. We just add our numerators. So 31 twentieths. 31 twentieths. That is an okay answer. Some of you may want to write that as a mixed fraction. That's fine. That would be 1 and 11 twentieths. But I'm not saying you must. I'm saying it's okay if you have 31 twentieths, because we're going to do a lot more of the improper fractions later. Okay, so both are great answers. Whoops. All right, let's get moving. What portion of this mixture do you think is red beads? I'll show you a picture. I want you to think, what portion is red beads here, right? Boy, I'm taking a look at that picture and thinking to myself, oh, there's more purples than reds. How much? I don't know, right? Let's go back to this. What could a portion be? You might say, oh, like 1/4. I don't want to use this in purple. Let's do this here. Some of you might be like, 1/4 of these are red. Maybe you had a different fraction in mind, and that's perfectly fine. You can write them as a fraction. Some of you might even had suggested a percent, like 25%. I don't actually know the correct answer, to be honest with you. I don't know if it's really 1 out of 4 or 1 out of 10 or 15%. I don't know. I don't know what the exact answer is. It doesn't matter. It's a matter of us talking about how do we illustrate, or how do we talk about how many red beads there are for somebody else, to somebody else, right? We say 1/4 of them are red beads, or 25% of them are, or 15%, right? It's a form of communication. Now, let's talk about percent. Percent is a number that can be written as a fraction with a denominator of 100. So 5% is, right, I'm just looking right in the middle, 5% is 5%, which equals 5 out of 100. And you can see down there, you could say 5 out of every 100. Now, it's really important for us to recognize, I got these colors coordinated for a reason. But before I talk about those colors, if we really talk about like that far left one, this one right here, whoops, that's not the one I want. I want the sorry about that. If we look at that right there, 5%. Now, you could say miles per hour, right? That's how many miles in 1 hour. You could say feet per second. So you could say how many feet per, or out of 1 second. You could say, we could talk about, going and having ice cream. We could say that it's $2.50 per cone, right? So that's a per something, meaning out of something. And so when we look at this, it says per cent, right? Per cent. Cent is something that might be, you might have heard, not just in money, but in other capacities, right? So cents, there's 100 cents in a dollar. A century has 100 years. A centurion, back into the Roman times, a centurion was somebody who was in charge of 100 men for these fights, wars and stuff like that, right? So cent means 100. That means 100. And per means, out of. So when we look at this now, let's start putting all these colors together. 5 per, let me choose a different color, per, or out of, or we could look at it like this, right? Out of, and we could say then cent, 100, 100, right? So I'm just trying to put all of those together to see all of this is there. Now look at that 5% sign right here. I don't know if you notice it, but it does look like there's 100 in there, doesn't it? A fraction and 100, right? That's kind of an interesting thought process. Wonder if that's why it exactly looks like that. Who knows, right? All right, so 5 per 100, and I'm just going to really hammer that. 5 per 100, 5 per 100. Okay, so we're going to use this per 100 ruler, right, percent ruler, to examine a sample of 40 in red, purple beads. So this is very much like a double number line. The double number line, and it would almost be like I gave you a ratio of 40 out of 100, 40 over 100%. Can you find the other ratios, right? That's our goal. Now, our real goal is to find, just to be able to answer the question, how many red beads would make 50% of the sample. 50% of the sample. So I'm really looking at for that. That's what I want. Now, we could probably cheat, and we could probably just say 50% is half of 100%, so this has to be 20. We could do that. And you know what? That's fine. By the next problem, though, we're going to be forced to find other information in here, right? It's not going to be so simple. So in this case, go ahead. Just divide them in 2, and we get that 20, right? All right, let's try it with this one. Use the percent rule to examine the sample of 40 red and purple beads. So here we are. We're back to that 40, right? Here's my 40. How many red beads would make 10% of the sample, right? So we are looking for that one right there. Okay, now, one thing to recognize up here is we divided by 2, or multiplied by 1/2. So we would divide by 2. So how do I get from 100 back here? I divide by 10. Or I could multiply by 1/10. So guess what? I'm going to do the same thing. That's the beauty of finding the 10%. is just divide by 10. That's 4, right? 4, and just in case I need it, I could do 4, 8, right? It's just a ratio. It's just a double number line. That's all this is. When the bottom increases by 10%, then the upper one increases by 4. 4, 8, 12, 16, 20, 24, 28, 32, 36, and 40, right? That's all this is. It's just a double number line, but it happens to have percents in the bottom, right? So what would it take to make 10%? The answer for that is 4, right? 10% of 40 beads is 4. Okay, how many red beads would make 10% of that sample? If I had 40 beads, I'd expect to have 4 red beads. All right, use a percent ruler to examine a sample of 40 red and purple beads. Okay, same thing, so I just put the numbers in there. How many red beads would make 1% of the sample? Oh, that's not on here. Well, let's keep in mind 1% is right here, right? What does it take to get from 10 to 1? Let's divide by 10. Guess what I do here? Divide by 10. 4 divided by 10 is 0.4. Now, I can't have 0.4 beads, but it starts, more importantly, it's not that I want to talk about being a half a bead or 4/10 of a bead or 3/4 of a bead. That's not the important part. The important part is we can find any number now. What if this were money? Or what if this were something else where we could have decimals in there? Well, I can do that now. So what would make 1% of that sample? How many red beads would make 1% of the sample? I guess 0.4 red beads. Right? 0.4, but that's not really a true bead or anything, but it gets us thinking a little deeper about what this could do for us, right? And then as a quick note, I want to take it one step further. How many red beads would make 12%? Well, I have all the same numbers that we just had before, but let's think about 12%. 12% is 10%. Oh, we know 10% plus 2%, right? And from our information up above right here, 10% is 4. What is 2%? 2% is a 1% and a 1%, or 0.8, right? So 12% is 4.8 beads. All right, so that's way deeper than I really have to go today, but I thought it was an interesting thing for us to discuss. All right, let's go further. How is finding the percent related to using the giant 1? This goes back to, we can multiply by that giant 1 to change percents, right? So if I go back to the 100%, and I want to know, and that was 40 beads, right? I'm using my giant 1, which is going to be an atrocious giant 1. I should have had a giant 1 up here, right? To say, what is it, to get to 10%, right? Whoops, I wrote that incorrectly, didn't I? Sorry about that. I should have those switched. All right, and we could say, how did we get to that 10%? We multiplied by 1/10, didn't we? Multiplied by 1/10. Right, so what's 40 times 1/10? That was the 4. That's all that work we found out before. So finding the percent related to using the giant 1, we did that. You just didn't actually show the giant 1. All right, let's get into practicing some problems. In a class of 30 students, 60% of the students are girls. How many girls are there in the class? Pause, try this. Okay, so hopefully you wrote the 30 here. I will just emphasize how super easy it is to get to 10%. Divide by 10. 3, 6, 9, 12, 15, 18, 21, 24, 27, and 30. Where's my 60%? 18. In a class of 30 students, 60% of the students are girls. How many girls are there in the class? 18 girls. Okay. All right. In a packet of 40 Skittles, 30% are red. How many red Skittles are there? Pause. Try. Right, since we're using red, I'll stay with the red. Here's the 40 Skittles, right? Go back and find 10%. 10% is 4. 4, 8, 12. Now, I don't have to go any further, do I? I don't have to. I could finish my percent ruler, but I'm good. In a packet of 40 Skittles, 30% are red. How many red Skittles are there? There's 12 red Skittles. There we go. All right. In a group of 90 children, 80% can swim. How many children can swim? How many children can swim? So let's use blue for children that can swim. Why don't you pause and try this one? All right, hopefully you wrote 90 here. You could go back and find what 10% is. 10% is 9. And we could go up and find what 20% is 18. Now, just for fun, I'm not going to fill in every single spot. I'm going to jump by 20s. 20, 20, 20, until I get here, right? I'm just increasing by 20%. You could totally fill in 9, 18, 27, and continue on. I am just showing you that we could just do it by 20%. 18 and 18 is 36, right? And then I could do, I'm drawing a blank here right now. I don't know why. I could do then up to 60%. I could get to 72, can't I? Whoops, I jumped too far too fast, didn't I? I doubled, and I don't need to double. I just need to increase by 18. Sorry about that. And then I would have 54, right? And then I would increase another 18 to get me to 72. Okay? Was it easy to do it with 18? Probably not. But I just want to show that we could increase by 20 or by 20% instead of 10%. Totally fine. Okay? All right. Last one. A toy car that is $50 is 25% off. All right, now what's the price of the car? Okay, so this one I want you to give it a try and see how you do. All right, let's think of what that toy car looks like. I don't know, it's a purple toy car, so we'll use purple. All right, there's $50. Let's go back, find the 10%. 5, so that's $5. 5, 10, 15. Okay, I could stop here, couldn't I? Because what's 25%? 25% is right there, right? 25%. And it's right between 20 and 30%. So this must be right between 10 and 15. And the number exactly between 10 and 15 would be 12.5%, or $12.50. Sorry. But if you wrote that as your answer, it's actually wrong. Because the key part is this is talking about what is 25% off. All right, so if my real price is 50, I could say, oh, it's $50. Oh, I don't know what happened. It could say, oh, it's $50. And 25% off, I'm going to take away 25%, and I could subtract that. Whoops, I didn't write the 50 in there. Sorry about that. Right, and I could subtract that, and I would have, 0. And I'm going to have to do some borrowing, and this become 10, and then it becomes 9 when this is a 4, right? But we get 37.5. You should be really good at these decimals by now. 3750. The other way to do it is to think about this. I'm going to move that down because I need a little space. So that would be correct answer, 3750. Another way to do it is 25% off puts me right here. Take 25% off of 100. That's right here. What's 75%? Well, if I continue my double number line, right, that's 20, 25, 30, 35. We'll stop here after this one. That's 40, right? And 75%. 75% is right here. And it's exactly between the 70 and 80. And what's exactly between 35 and 40? 3750, right? 3750. Okay, so that one was just a nice little, hey, make sure you're answering the question correctly and you understand it. Okay, if you have any other questions, please let me know. Have yourself a great day.